Okay, so we will be talking about moles to moles, moles to mass, and mass to mass ratios. We are going to be talking about stoichiometry. The first part of stoichiometry we're going to talk about is moles to moles. This is, in my opinion, the easiest because you don't have to convert anything. So let's start off with a balanced equation. So to go from moles to moles, all you need to do is look at the mole number in front of each section of the equation, of the balanced equation. So you'll be looking at the number that's in each beginning of the section. So you have 1 mole of aluminum bromide. You have 3 moles of NaOH, and 1 mole of aluminum OH3, and 3 moles of NHBr, sodium bromide. So, let's say that my question asks, how many moles of sodium bromide can form from 150 moles of aluminum bromide? All you would need to do is count 1.5 moles of AlBr3, which is our given. And since we know that if you're going to find your product, which has to be in moles, you need to first ask for the same thing. So we have aluminum bromide, so you would also write aluminum bromide here. And we know that it's 1 mole. Now, 1 mole of AlBr3 is equal to 3 NaBr, because this is our ratios. If it's on one side, it's always equal to the other. So it'd be the same for 1 mole of aluminum bromide and 1 mole of AlOH3, or 3 moles of NaOH is equal to 3 NaBr. That's just the way it works. So if I want to find sodium bromide, all that we need to do is put that over this, NaBr. So we started with moles, and now we're ending with moles. That equals 4.65 moles of NaBr if you put it into a calculator. So let's move on. We're going to moles to mass. So that means that we're starting off with moles and we want to end in mass. Mass is usually in the units of grams. So our equation is N2 plus 3H2 is equivalent to 2NH3. So let's say our problem asks how many moles of nitrogen are required to produce 11.7 moles of NH3. So we're looking for nitrogen, and we are given 11.7 moles of NH3. So we have to start off with our given, which is 11.7 moles of NH3. And since we still need NH3 to match up with this, we're going to put our 2 moles of NH3. And since we want N2, and we know that 2 moles of NH3 is equal to 1 mole of N2, we're going to just put that right up here. And if you put that into a calculator, you will end with 5.85 moles of N2. moving on, we will be doing mass to mass ratios. That means we'll be moving from grams to grams. This is probably the most difficult because most of the time, you will need to move from grams to moles back to grams. But that won't be hard if we know our ratios. So let's say our question asks, how much zinc will be needed to prepare 4,500 grams of hydrogen from sulfuric acid? Well, for this problem, you will need a periodic table, so you know how many grams are in each element. So for this equation, you will need to know how many grams are in each element. So you will do zinc. Let's start off with what we're given. 4,500 grams of H2. So we still need to get our grams of H2, so we're going to put 202 grams, because that is how much grams are in 2 molecules of H. And 1 mole, that is equal to 1 mole of H2. And 1 mole of H2 is equal to 1 mole of 2NSO4. And that is equal to 1 mole of zinc. And 1 mole of zinc is equal to 6.34 grams. If you put this in your calculator correctly, you'll end up with about, since we have to do our significant figures, 150,000 grams of zinc.